Today we're going to be taking a look at 12.3 notes. Our objectives will be to find lateral areas and surface areas of pyramids, as well as with cones. So we'll start here with the definition of a regular pyramid, which has a base that is a regular polygon. The altitude has an end point at the center of the base, so the altitude goes from the center, goes all the way up to the point that we call the vertex. Okay, so that goes through the pyramid here, and then we also have a measure called slant height, which we use L to represent slant height. And slant height comes from it lies on one of the triangular faces here, and so it goes kind of up the side of the pyramid. It is perpendicular to the base, but comes from the top of the pyramid, goes down that lateral face to the base. All right, we won't worry too much about non-regular pyramids, but there is an example of one. So lateral area of a regular pyramid, L equals 1/2 perimeter of the base times the L, which is slant height. So you can see you need perimeter of the base. These are regular polygons, so all sides are congruent. So add up all of the sides of the base, multiply that by the slant height, and then 1/2. So find the lateral area of the square pyramid. So here it looks like one of the base edges is 4 inches, so all of the base edges are 4 inches. So if we're going here to find lateral area, 1/2 P times slant height. 4 sides, all 4 inches long, so the perimeter is 16 inches. The slant height is marked 6 inches. So multiply these together and you get that the lateral area is 48 inches squared. So that's our first example. Right. Here it's kind of just described to us. Find the lateral area of a regular hexagonal pyramid with a base edge of 9 centimeters and a lateral height, slant height of 7 centimeters. They call it lateral height. We'll call it slant height. That's our L, 7 centimeters. Okay, and let's draw the base of this pyramid. It's hexagonal, a regular hexagonal pyramid with base edges of 9 centimeters. So each side of a regular hexagon would be 9 centimeters. So to find the lateral area, that's 1/2 perimeter of the base. Perimeter of this base would be 54. 9 times 6. 54 centimeters times the slant height of 7. Multiply that together. Get a lateral area of 189 centimeters squared. Okay. Now let's talk surface area of a regular pyramid. All right, so a regular pyramid has only one base. So if we find the area of the base and then add it to the slant height, we would find the surface area of the entire pyramid. So that's how the surface area formula is reflected. It's surface area equals, that should look familiar, as lateral area plus the area of the base. Again, these are regular pyramids, so each polygon, each base of the polygon is a regular, each base of the pyramid is a regular polygon, so we've got to find the area of a regular polygon to do many of these calculations here. So that's kind of a way to bring chapter 11 back into this lesson as well. So surface area of a square pyramid, find the area of the square pyramid to the nearest tenth. All right, if you look at this example, we are given the altitude of the pyramid, 16 centimeters, and we're given that the base is 12 centimeters, the base edge. We are not given slant height. However, if we take a look, if we draw the altitude and the slant height, that is a right triangle inside of my pyramid here. And this one would be the altitude, 16 centimeters. And this is half of the base, this bottom leg here. So that would be 6 centimeters. So you can use the Pythagorean theorem here to find the lateral area. So you would just go leg squared plus other leg squared got is that this will be the square root of 292 is equal to L. All right, the square root of 292 is, I'm going to get a calculator out here, 17.1. Make sure I've done that right. 6 squared. Yep. So 17.1 is the slant height. All right. So to find surface area, we need 1/2 perimeter of the base. Base edge is 12, so perimeter would be 48. Slant height, we'll go 17.1 plus area of the base. The base is a square, so that would just be 12 times 12, 144. So surface area, plug all of this in, and you will get 554.1 centimeters squared for surface area. All right. So find the surface area of the regular pyramid, round to the nearest tenth. So on this one, I'll leave this one to you guys. You have the slant height, so you don't have to worry about that. You have the base edge, so you can find the perimeter. Here you're going to have to find the area of the regular polygon. You're going to have to find the area of the base, which is a regular hexagon with side lengths of 5 centimeters. So you'll want to find the area of that. Area of your hexagon, which if you guys recall, is 1/2 perimeter times apothum, or apothum times perimeter, rather. Okay, so that one's for you guys. All right, so surface area of a cone and lateral area. So lateral area is pi times radius times slant height. Slant height is kind of the same concept here. We're looking at right cones. Slant height is the measure from the point down to the base edge there. Surface area, pi times radius times slant height plus pi r squared. So the conical slate roof at the right has a height of 16 feet and a radius of 12 feet. Find the lateral area. Here this diagram is just showing you we've got to use the Pythagorean theorem to find slant height. So we would go 12 squared plus 16 squared is equal to my slant height squared, and we would use the Pythagorean theorem here, and we should get a slant height of 144 plus 256, so that's 400 equals L squared square root. We get a slant height of 20 feet. Right? So let's just find lateral area. Lateral area is pi times radius times slant height. Pi radius 12, slant height 20, and you should get a lateral area of 753.98 feet squared. Right. Last example here, surface area of a cone. Okay, so surface area is, again, pi times radius times slant height plus pi r squared. Here we're given the diameter is 14.8, so the radius would be 7.4 centimeters. Slant height we're given is 15, so we just plug in pi times radius 7.4 times slant height of 15 plus pi times 7.4 squared. Plug all of that in. We get a surface area of 520.7 centimeters squared. Here at the bottom of the note, let's kind of just have a summary of the lateral areas and surface areas that we found. The formulas, again, I'll give you guys these formulas, so no worries there. Just how do I use them? Here's your assignment for 12.3. Thanks for watching today, guys.